this video, you're going to learn about translations. Translation is the movement of a point or an object on a coordinate plane where it slides right, left, up, and down. And it's one of the transformations that we are going to be learning about in this unit. Please use a ruler for all of your transformations when you are drawing coordinate planes and objects. I know I am not a very good model for that in this video, but it's very difficult to write on an iPad and make sure that the lines are as straight as you'd want them to be on a piece of paper. So in this video, you're going to learn translations, which is also called a slide, because you are taking a point or a shape and you are sliding it around the coordinate plane. A positive number means you're either going to the right or you're going up, depending on whether that positive number is applied to your x value, which would make you go to the right, or to the y value, which would make you go up. And a negative number means you go left if you're on the x-axis, if you're a horizontal move, or down if it's a vertical move. So you can see that there are a couple of different ways that you can write a translation. So if you see the T and then a subscript of -2, 3, it means the -2 is the X movement and the 3 is the Y movement, because we know that the first number in an ordered pair is the X and the second number in the ordered pair is the Y. So the -2 will be applied to the X and the 3 will be applied to the Y when we move the point A in the coordinate plane. Or, like you see on the bottom, you can just have a x minus 2, y plus 3, where you would take the coordinates of your point and you would simply plug them in for the x and the y, and that will tell you that the x will move left and the y will move up, because it's a subtraction for the x, which moves it left, and an addition for the y, which moves it up. So when you take that original point or that original shape and you apply the translation, you're going to have what's called an imaged point. And imaged points always have what we call prime notation. So if the original point is A, the prime notation would be A prime. And this notation is for any transformation. So when we get into the videos on reflections and rotations and dilations, you're going to see that the prime notation stays. Okay, if you happen to do more than one transformation on an object, the first image is A prime and the second image would be A double prime, assuming that your point is A. If your point was B, then it would be B prime and B double prime, and that would go on forever. B triple prime, B quadruple prime, depending on how many transformations that you do. So let's get to the slide, the coordinate plane that you see in front of you. You have a point A, and it's telling you that you have to go -2, +3. So the original point A has coordinates of 5, 2. So that point is 5 to the right and 2 up. So the coordinates of that point are 5, 2. To that point, you're going to subtract 2. So your x value is going to be 3, and you're going to add 3. So your y value is going to be 5. So your A prime is going to be at 3, 5. So when we plot that point, we notice that A prime now has an x value of 3 and a y value of 5, because we subtracted 2 from the x and we added 3 to the y. And this would go for a point or a shape. Anything on a coordinate plane that you're applying a translation to, you have to remember that the imaged point uses prime notation, and that if it's positive on the x, it goes right. If it's negative on the x, it goes left. If it's positive on the y, it goes up. If it's negative on the y, it goes down. So here's triangle ABC. It's on the coordinate plane. The coordinates for A, B, and C are on the left side of your screen. And we are going to translate the entire triangle 2 spaces to the right and 4 spaces down. So that means I'm adding 2 to my x value and I'm subtracting 4 from my y value. So if A originally started at -1, 3, -1 plus 2 will give me 1. So my x value will be 1. So A prime will have an x value of 1 and a y value of -1. That means I went over 2 and down 4 and got my A prime. Now my B prime, if it started at 2 and I added 2, I go to 4. And if it's 5 and I subtract it 4, I go to 1. So my B prime is 4, 1. And then my C prime, it started at 3, 3. So when I added 2 to my x value, I got 5. And when I subtracted 4 from my y value, I got -1. So my C prime was at 5, -1. When I connect the dots for my triangle, ignoring the tiny dot that my finger just created, my triangle A prime, B prime, C prime is now congruent. That means exactly the same in every way, shape, and form, area, perimeter, angle measurements, side measurements, as triangle ABC. All I did was take ABC and slide it 2 spaces to the right and 4 spaces down, keeping the shape the exact same. So if you look at side AC and you count the boxes between A and C, you get 4. If you go down to A prime, C prime, and you look at that segment, you should see that A prime, C prime is also, the distance between A prime and C prime is also 4 boxes, because everything about triangle ABC is completely congruent to triangle A prime, B prime, C prime. And this will be the same, this will stay the same for reflections and rotations as well. No matter what you do, reflect, rotate, or translate, your original shapes are congruent to their images. Everything about the shapes are exactly the same.